everyone. In this class, I will take up 3 different types of problems in which there are few misunderstanding when we apply the concept of friction. For example, most of the time we think that friction acts always opposite to the direction in which the body is moving. Now let me take few examples. This is the first example. There is a block, bigger block kept on a surface which is very smooth, so there is no friction between the two. There is another smaller block kept onto it, but there is frictional force between these two. Between a smaller m and bigger m block, there is a frictional force. Now if I apply a force onto this body, bigger block, then this will move with it. This is just like we have a duster and I keep an object onto it and I am applying force on the lower one and this one is moving. The pen is also moving with the duster, but I am not applying any force on this pen. So, but it is accelerating upward. So if the block is accelerating in forward direction, it means the pen kept onto it is also accelerating in forward direction, though I am not applying any force on that. So how it happens? So I have taken one particular problem. We have to find out the maximum value of F to be applied on M so that these blocks move together. Okay. If I apply a very large force onto F, this M may fall down. Now let us say, let us find out what are the forces on this smaller block. One is the weight. Weight always acts downwards. Normal reaction. This is the normal component of contact force. So the contact force between them, and it is acting in this direction. Let us call it M. This is applying force onto it, so this will apply force onto it. This is M, and these are same. So this is applying a force, weight, its own weight on this block. This will apply equal force onto it in upward direction. Okay, but this block is moving forward. It is accelerating in forward direction. Now see what is the direction of frictional force acting on these blocks. I can take bigger block also. So on bigger block, there is a force mg, and then there is a force, normal reaction of this surface, and there is no friction. Friction here is 0 on this surface. But there is a contact force. What about the tangential component of the contact force between the two bodies? This is moving forward. This is kept onto it and accelerated forward. It means the direction of friction actually on this is in this direction. That's the only force acting onto it. And on the bigger block, it will be in this direction. And there is another force also onto this. This one is applying a force onto it, weight. Okay. So these are all the forces acting on the upper block. Normal reaction, mg, they balance, and this frictional force provides the necessary force basically, which is responsible for the acceleration. And we are saying what maximum force? It means we have to take the limiting friction. And how much is that limiting friction? This is limiting, I am writing mu s into n. So it is mu s, and from here n it is mg. Right? And these are accelerating in forward direction. So mu s mg, this force, frictional force, it is equal to mass into acceleration, Newton's second law. So from here we can find out that the acceleration of this block is mu sg, and they are moving together. So it means this will be the acceleration even of this. So we can find out the force. F is, I can take it as the entire system. There is no friction here. External force only F. So F is M plus M into A. And A we have just calculated from here. So it is, this will be the answer. This is the maximum force that can be applied on this system without this M slipping on the lower block. So frictional force may act in the direction in which the body is moving. Rather, this is being accelerated because of frictional force. Now imagine if there is no friction force between the two bodies. If there is no friction, what will happen? You apply a force onto this block only will move forward, not this one will fall down. If there is no friction between this and this, so if I apply a force onto this will remain here only and it will fall down. So it is the friction between the two which keeps them in motion together. Here you can frame other equations if required, it depends on the problem. So normal reaction will be the sum of M plus mg. Had there been friction on this surface, the problem would be then different. Now let me take another problem in which we will see that the friction can be zero at a point. What does it mean? If I take that a body is moving like this and ask you to find out the frictional force at this point on this, then it is taken to be zero. At one particular point the body does not have any tendency to slip, so it will be taken as zero. Now keeping this in mind, let us solve another problem. It's just like a speed breaker, and we will find out the normal reactions, the frictions at different points. The first says to find out the normal force by road on the cycle. A cyclist is moving on this track with a constant speed of 18 kilometers per hour. So in meter per second it will be 5 meter per second. Theta, these tracks, the extremes, they subtend an angle of 90 degrees for both. It can be any angle. Okay. And the radius, this is 100 meter. The speed breaker, they don't have very less radius. So the curvature is kept such that the radius is very large. It is less. Okay. Okay. So now normal force by road on the cycle at this. So we have to just mark the forces, free body diagrams, and then write the equation whenever a body is moving on a circular path or a part of the circle. If it is able to negotiate that part, it means the force towards the center is sufficient to provide the necessary centripetal force, which is mv square by r. So on any curved path or circular path, if the body is making that motion, the force towards the center, it should be equal to mv square by r. So see at this point now, what are the different forces? mg downward, normal reaction upward, no friction here. Okay. So n is equal to mg and the net force is towards the center. So mg minus n. This is the force acting towards the center and it should be equal to mv square by r. So normal reaction will be mg minus mv square by r. Okay, this is the reaction, this is the equation. If you have to find out the values, just substitute the values. This is mass is not given. So mass you can also take 100 kilogram. So 100 into 10 it will be 1000 minus 100 by 100 into v square 25. So 1000 minus 25, it comes out to be 975 meters. Okay. Then normal force by road on cycle at B and D. Okay, so at B this is the force. What about the point D? When the cyclist is here, mg is down, n is towards the center, upward, and this time the center of the path is here. Okay, so n minus mg is the force now. So n will be equal to mg plus mv square by r. So in this case, the sum of these two, it will be 1025 Newton. So see, when the cyclist is moving with a constant speed, the normal reaction is not just mg. Normal reaction, if I take I make a flatter part and say the cyclist is here, now what is the normal reaction? Then it will simply be mg. N will be equal to. So on a flat road, N is mg, but the moment it takes a turn, it takes a curve, then N is no longer equal to mg. N is different from mg. And we can find out the values like this. Okay. Now, so this is how we can find out normal reaction. I have done it at these 2 points. At these points also, if I say what is the normal reaction at say C. Then again, find out mg is down and this is half this side, so this will be 45, right? So this will be mg cos theta, this will be mg sin theta, this is mg cos theta, the normal reaction will be like this. I'm taking just before C actually, right? So the equation now will be mg cos theta minus n is equal to mv square by r. So n is going to be now mg cos theta minus mv square by r. It is just before C. Okay, just after C the situation will be different. What will be the difference? Let me write it. Just before C. And now let me see what is happening just after C when it crosses this. When this has been crossed. So in that case, mg is this, mg cos theta, mg sin theta. So the equation will be now n minus mg cos theta is equal to my square. So n is now mg cos theta plus mv square by r. See, up to this point, the curvature is like this. So center is here. But after it, the curvature is in opposite direction. So the centripetal force needs to be towards the center. Here it needs to be towards this point. So normal reaction will change from this to this as the point C is crossed. So normal just before and after C. So this is the answer. Okay. Now, and you can substitute the values and find out. Okay, now frictional force by the road on B, C and D. So at B, frictional force is 0. Frictional force at B, 0. At D also 0. I told you that if there is just a point we take friction, 0. No tendency to slip. Okay, what about C? Frictional force. See, mg sin theta, and this is the direction in which the friction will act. And the body is moving in this direction. Actually, the body has net force is 0. Why? Because it is moving with constant speed, so there is no tangential acceleration. We have only the radial acceleration, v square by r. So tangentially there is no acceleration. It means this component, it's moving like this. mg sine theta is along the surface, minus friction, it is upward, and it should be equal to ma, which is 0 because the speed is 5 meter per second, constant speed. So the frictional force is mg sine theta. You can substitute these values. 1000 sine theta is sine 45, so 1 by root 2, and then solve it. Okay, so it will be 500 root 2, 700 Newton. Okay, so this is how you can find out. Again, I'm telling you, whenever on a curved path, n is no longer equal to mg now, because the resultant will provide the necessary centripetal force to keep the body on that circular track. So n minus mg will be equal to mv square by r, or mg minus n, depending on how that road, that surface is curved. If it is horizontal, then n is equal to mg. Okay, so in these cases the friction is 0 here, friction is 0 here, but here the friction at any other part, actually it's not 0, but since we have taken that it is moving with constant speed, so it means the net force is 0. So at any point the frictional force, which is acting opposite to the motion, and the downward force, they are equal. So you can equate them to find out the value of frictional force. So minimum friction to ensure that the cyclist move with constant speed is, okay, so we have found the normal force at different points, friction at B, at C, at D. Now minimum force to ensure that the cyclist move with constant speed. So in this, friction is mu n. So actually we have to find out, and it has the constant speed, so it means frictional force mu n, it is, and we have seen how it is equal to n is mg minus n is equal to mv square by r, n minus mg is equal to mv by square r, and at these points we have seen just before and just after also, mg cos theta minus n is equal to mv square by r. After crossing it, it is n minus mg cos theta is equal to mv square by r. So if we want minimum friction, just see when is the minimum force acting on the body and equate it with mu n. We calculated this force, see, at this point, just before C and just after C. Just before C, it was mg cos theta minus n is equal to mv square by r. So n comes out to be mg cos theta minus mv square by r. It was just before C. Then just after C, it is n minus mg cos theta is equal to mv square by r. One more thing, we can generalize the problem. Even the radius can be different over the two tracks. Even this angle can be different. I'm telling you a general way of solving all these problems. Okay, so here n is mg cos theta plus mv square by r. So it's clear in all these that this will be the minimum value of n. mg is 1000 by root 2 minus 100 by 100 into 25. 1000 by root 2 is 700. I'm taking root 2 as 1.4. 700 minus 25, so it becomes 675 Newton. And it will be the addition of all this. So it will be 700 plus 25. It is 725 Newton. Okay. And at these points we have found this is more than this. okay, because for this point it was normal force at, it was around 1025 or 975, we calculated that is more. And we want that the minimum friction to ensure that the cyclist move with constant speed. It means if he is moving with this speed, when this normal reaction is minimum at whatever point, that will determine the frictional force. Friction is mu into n. So if he has to cross this track without getting slipped, so we should have minimum mu n, and n is coming minimum for 670. What is the frictional force acting at any point? F is mg sin theta, because it is moving with constant speed. So at this point minimum is at c, so it is 1000 1 by root 2, so 700 Newton. Right? 700 Newton is the force acting in downward direction along this, and this should be able to balance the frictional force for not getting slipped. And 700 is mu times 675, so mu is 700 upon 625, it will be 1.03 and something. You can calculate this later. Okay. So we have to find out what is the actual force acting on the body due to which it may slip, and the frictional force should be able to not to let it slip, and frictional is mu into n. So see what is the minimum value of n. Okay, so that is the minimum value of friction, and that should be equal to the net force acting on the body along the incline. So net force along the incline is mg sin theta, and mu n, minimum value of mu n is mu into 675. This will give you the friction coefficient which will help the body to take that up.